This lesson is going to go over measuring segments and subsets of lines. Okay, so starting off, we have our ruler postulate. The points of a line can be put into one-to-one correspondence with the real numbers so that the distance between any 2 points is the absolute value of the difference of the corresponding numbers. A coordinate is a point's distance and direction from 0 on a number line. So we have an example here, just kind of talking about how you could possibly find the length of the segment AB. And if we actually had numbers, you could plug them in, but it would just be the absolute value. So that's what, if you remember, those lines here mean. And then we can just subtract our A minus B. Okay, when you are talking about the length of a segment, then there's no line needed above the 2 points that you are using to name it. Okay, let's look down here at our segment addition. Okay, so segment addition, if points A, B, and C are collinear, so if you remember, collinear means that they lie on the same line, and B is between A and C, then you can say that AB plus BC should be equal to the entire line AC. And a lot of times I will, instead of using those letters to kind of name out the segments, because it won't always just be using those exact letters, I will sometimes just say part plus part equals whole. Okay, in our next section, we have congruent segments. A congruent segment are just segments with the same length. Okay, so big thing to kind of note with congruent segments, well, actually with segments in general, as I mentioned up above, when you are writing it this way with the equal sign here, they are referring to the length of the segment being equal. And then here, with the congruent symbol, because that's what that symbol is with the equal sign and the squiggly on top. And then the way they have it written, they are referring to just them naming those segments. Okay, and the picture over off to the side here next to kind of what I was writing, these right here are just showing that since these two segments, AB and CD, were given to be 2 centimeters each, then we can say that they are equal, they are congruent to each other, okay? So the way you show segments to be congruent is by those dashes, and when you have different amount of dashes, you would just pair up the ones with the same amount, okay? So just for an example, and I'll erase it right after. If I was looking at up here, AB being congruent to this BC, instead of necessarily doing the 2 dashes, maybe I could just do the 1 dash, and that would be fine. Okay. The biggest thing is just when you do have multiple congruent segments in a picture or in a diagram, you want to label the ones that are equal to each other, are congruent, with the same amount of dashes so that you can tell which ones go together. All right. So going back to the rest of what we have here, a midpoint is a point that is going to divide a segment into 2 congruent segments. Okay, so kind of how it sounds, it's a middle point. So looking at what they have, they're asking us to determine what the midpoint is. So the point that's in the middle would be that point B. And then we have just naming our congruent segments. So AB would be congruent to BC. Okay, so now let's look at some practice problems. Okay, and number 1, we have that EG, so this entire line here, is equal to 100. And then they're asking for us to find the value of X. And once we do that, we will then plug it in to find EF and FG's lengths. Okay, so looking back to what we had talked about up above with our segment addition, we can use that part plus part equals whole. So my first part that I come across is that 4x minus 20 plus, then we have 2x plus 30 should be equal to the entire length, which they gave us was 100. Okay, so just going through and solving for our variable, I'm going to combine my like terms. I'm going to get 6x plus 10 equals to 100. When I subtract that 10 to the other side, I'm going to be left with 6x equals to 90. And using division, I know that x is going to be equal to 15. So that's going to be one of my 3 answers. Now we just need to plug it in so that we can find the segment lengths that they're asking for. So for EF, that's my 4x. Okay, so where I have that x, I'm going to replace it with 15 using substitution, minus 20. Okay, well, 4 times 15 is going to give me 60. And then minus the 20 should be equal to 40. So EF is equal to 40. Now to find FG, you could always take the entire length, the 100. So I'm going to do this 2 ways just to start off by saying that. So you could take the 100 and subtract the part of the whole line that we do know, which is that 40 we just found. And I should get 60. Okay, so that's one way of doing it. But a lot of times when I do these problems, just in case I have a small error, I do like to just plug it in. So just plugging in, we would have that 2 times my x, so 15, plus 30. And 2 times 15 is 30. So 30 plus 30 gives me 60. This is just a nice way to make sure that if I do have any mathematical errors in that first solving part of it, that when I do plug it into both, they probably won't add up to that 100. And so that's going to be a clear indicator that I need to go back and double check my work because I probably made a mistake. Okay, so that's just why I do that. But it's completely up to you as long as you're showing me the work of how you got your answer. All right, moving on to number 2. So for number 2, we have if AB equals 25. Okay, so just drawing out that the whole line is 25. I want to find the value of x and then find AN and NB. Okay, so then I'll just plug it in. So doing exactly what we did in the first one, we're going to start off by just adding our 2 parts. So 2x minus 6 plus x plus 7 should be equal to the entire length of 25. Combining like terms, I'm going to get 3x plus 1 equals to 25. And then I'm going to subtract that 1 from both sides so that I have my constants all together. So I'm going to get 3x equals to 24. And using division, when I divide both sides by 3, I'm going to be left with x equals to 8. Okay, now using substitution, I'm going to plug in for AN. So I get 2 times that 8 minus 6. Well, 2 times 8 is going to give me 16 minus 6. I will be left with 10. So AN is equal to 10. Now plugging in for NB, I have 8 plus 7 equals to 15. So NB equals 15. Once again, that's another scenario where since I do know one of the lengths now, I could have subtracted from the whole, but it might be helpful just double check my math, making sure that they do add up to that 25 if I just plug it in to see what I get. All right, so last one on this front side. We have M is the midpoint, so in the middle of RT. We're going to find our M, MT, and RT. Okay, so since it is a midpoint, I'm going to go ahead and just label it as such. And remember, midpoint means it's in the middle. They are congruent. Congruent just means that those 2 segments should be equal to each other. So I can set them equal to solve. So I'm going to get 5x plus 9 equals to 8x minus 36. Okay, so subtracting 5x from both sides, I'm going to be left with 9. And 8 minus 5 leaves me with 3x minus 36. Okay, adding my 36 to both sides, I'm going to get 45 equals to 3x. And when you divide both sides by that 3, you will be left with x equals to 15. Okay, I'm not going to highlight that one just because that wasn't one that they were asking for, but I do need it so that I can plug in and find the other lengths. All right, so let's start off with our RM. So RM is 5x plus 9. So I'll have 5 times 15 plus 9. Okay, so 5 times 15 is going to give me 75. Plus that 9, I will be left with, let's see, quick math, 84. Okay, so RM equals to 84. Okay, and since, once again, kind of like what we know up above, we know that they are congruent, they are equal. So you might go straight into that MT is equal to 84. But like I do with the previous one, just a way to double check myself, make sure that, I don't mess this up. I'm going to plug it in and just see if I'm going to get that same 84. Okay, so my 8 times 15 should give me 120. Minus 36, and I'm left with 84 as well. So MT is equal to 84. Okay, and then the final part of what they're asking for, we have RT, which is just the whole entire line. So I'm going to add my 2 parts, so 84 plus 84, or since they are equal, you could always say 84 times 2. And when I add those two, I should get 168. Okay, so now we're going to move on to the back side with our subsets, union, and intersection that we're going to go over. Okay, so we're starting off with our subsets. So a subset means that the first is contained inside of the second. Okay, so everything in the first one should be inside of the second one. And it's going to be represented by this little squished up C. Okay, so we do have an example here for us to kind of refer to. And they're saying ray EF is a subset of ray DG. Okay, so you'll see up above here, I kind of draw these out into representations of what it's showing. So I have my ray, let's say green will be my EF. So starting at E towards our F, and we're just going to keep going since it is a ray, it won't stop. We want to know, is everything in that first one going to be inside of the second one that's named? So ray DG. So starting at D, going towards G, that would be this ray here. Okay. Well, yes, everything in the green is inside of the blue. So this is a true statement. Okay. Moving on to our union. The union of two rays or segments is the sum of the two rays or segments, and it's going to be represented by the U symbol. Okay, so unlike with the subset one where we're going to be answering true or false, this one we're actually going to name what can we name that will include everything that we are marking. Okay, so this one having multiple colors won't really matter because we want it to just include everything. So I'm just going to use the green one that we have. And they're saying segment DF. And they are also stating that we want to use the ray EG. So just keep going after that G. We want to know what can we name that will include all of what we have highlighted, okay? Well, we're going to have to start at D, and because one of them is a ray and it will never stop, we need to name a ray starting at D, right? And that just keeps going in that same direction. So there's a lot of different ways, and I've listed off all three of them, but ray DG, you could say ray DE, or you can even say ray DF, okay? All of those ways of you naming it will say that you're starting at D and you keep going all the way past G. All right, so now let's move on to our intersection. The intersection of two rays or segments is where they cross each other and is represented by this symbol here, this symbol that looks like an N. Okay, so we have an example. They're asking, what is the intersection of ray EF, so starting at E and going towards F, and ray G going towards D. Okay, so we want to just look and see, where do these two overlap? So I usually will just kind of color it in. And it looks like we're going to have a start and a stop, right? So that's going to be a segment. And so we just want to look at the two endpoints, the start and the stop. And that would be our E and G. Okay, so you can either call it segment EG or you can call it segment GE. All right, so now let's look at some practice problems below. Okay, so for number 1 and 2, given D, E, F, and G are collinear points, so once again, remember that means they're on the same line, as shown in the diagram. Answer true or false. Okay, so looking at number 1, I'm just going to highlight the two so I know which one I have for each one. All right, so we have, is FG, so ray FG starting at F going towards G, a subset, so is it contained inside of ray E G? Okay, so is all of the first, the green, inside the purple? That answer is going to be true. Okay, now let's look at number 2. So I'm going to still go ahead and highlight the two. So I'm going to do the first in green and the second one in purple. Okay, so is ray EF, so starting at E going towards F, a subset of segment EF? So is all of the first, my green one, contained inside the second, the purple? Well, that's going to be a false statement. All right, we can see that that green is going to continue even past where that purple stops. So that's good. All right, so now moving on to our union and intersection practice. So for these, we've got pretty much the same instructions, but if D, E, F, and G are collinear points, as shown in the diagram, answer the following. Okay, so something to kind of just use as a hint up above when we were given our instructions, they did specifically tell us to answer true or false. But if we look at these problems down below with our union and our intersection, we don't have that. So with these, we should not be writing true or false. Okay. With these ones, we are going to name whether, for the intersection, it was a ray or a line or a segment where they overlapped. And same with the union. Okay, so whether it was a ray, a line, or a segment where we were including all of it. Okay, so let's look at these problems here. With number 3, we have, what is the intersection of, we have ray FD. Okay, so starting at F, going towards that point D, and ray EF. Okay, so once again, this is an intersection, so we are looking for the overlap. Where do the two overlap? So we can see here that the two are overlapping from E to F. Okay, nowhere else, so it's a start and a stop. It should be us naming a segment here. But also remember, you could also call this segment FE, and you would be correct as well. All right, let's look at the next one. We have, what is the union of ray ED, so starting at E, going towards D, and ray EG. Okay, so remember, union is we want to name something that will include everything that I just outlined with those two rays. Okay, in order to include everything, we will just be naming a line. Okay, because it's going to actually be opposite rays here. And remember, opposite rays are just going to be that line. So naming a line, remember, you can pick any 2 points on the line. So I'm just going to do D and G. And then we are going to put that line with the 2 arrows showing that we want it to keep going past those 2 points of D and G. Okay, next one, number 5, we have the intersection of segment EG and ray FE. Okay, so intersection, once again, that's the overlap. So we want to just see where are these two overlapping, and that's going to be from that point E all the way to point F. Okay, or I'll just do the reverse since I did it EF before, and we'll just say segment FE also works here. All right, last problem. So we have, what is the union of ray EG and ray GE? Okay, so once again, union means we want to name something that will include everything that we have just now marked up. And like we talked about in number 4, in this case, based off the 2 rays that they gave us, we are wanting to name a line. So this one wasn't made up of our opposite rays like number 4, but it is still 2 rays going in opposite directions. So for us to name this, we will be naming a line. And remember, you can pick any 2 points. I'll switch it up. We'll go with GE. And then we'll have that line with the 2 arrows above it. Okay, so I know in these 4 examples here, it came out to be segments and lines, but remember, it could also be, depending on what they're giving you, it could be a point, so that's one we haven't really seen, but maybe when you're doing your homework, you might see some practice ones of, or it could be a ray as well. It just kind of depends on what they're giving you. Okay, so that's it for our lesson for today.